All right, what we are going to do is just get started on our next lesson. We are not going to do all of these notes in the video, just a little bit. What I want to, excuse me, get started is for you to be able to identify the three basic trigonometric or trig ratios. And then next time we'll use those to actually find some side lengths of triangles. So the word trigonometry is from the Greek language. It means measurement of triangles, which makes sense because we can use trig to find missing angles and sides of triangles. A trigonometric or trig ratio is a ratio of the lengths of two sides of a right triangle. We have three basic trig ratios. They are sine, abbreviated as SIN, that is sine, not sin. We have cosine, which is abbreviated COS, that is still pronounced cosine, do not say cos. And finally, tangent, which is abbreviated TAN. You still pronounce that tangent. Sine, cosine, tangent. All right, so what are these three ratios? If we have triangle ABC, the sine, cosine, tangent of the acute angle A. So let's highlight angle A. This is the one we're finding these with respect to. So with respect to angle A, that is the opposite side, and the one next to it is the adjacent side. The ratio for the sine of angle A is the length of the opposite side over the length of the hypotenuse. For cosine, this is the ratio of the adjacent side over the hypotenuse. And for tangent, this is the length of the opposite side over the length of the adjacent side. Now, you will have to know these ratios, but there is a little mnemonic device that we can use to remember this. It is SOHCAHTOA. SOHCAHTOA. So let's see what this means. S for sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. All right, so we'll look at one example. We're going to stop after this example, but let's look at finding the sine, cosine, and tangent for angle A for each of the following triangles. So again, I always take a highlighter and highlight the, ignore the phone ringing. I always highlight the angle that we're finding those with respect to. So let's find sine, cosine, tangent for those angles. So let's start with sine of angle A for the big triangle. Sine of angle A is the opposite side, so 8, over the hypotenuse, which is 17. And we're just going to leave it as that fraction. Let's find the cosine of angle A. So cosine, again, is adjacent over hypotenuse. So the side adjacent to that angle is 15. The hypotenuse is still 17. And then finally, we need tangent of angle A. Tangent is opposite over adjacent. So the opposite side is 8. The adjacent side is 15. All right. For the second triangle, again, with respect to angle A, we're going to do the same thing. Sine of A, cosine of A, tangent of A. All right, so sine of A, that's opposite, so 4 over hypotenuse is 8.5. cosine of A is adjacent, so 7.5 over the hypotenuse, which is 8.5. And then finally, tangent is opposite over adjacent, so 4 over 7.5. So what we've done is we have written out all of the ratios. We are going to divide those out in just a second because there's something I need you to see. But let's think about these triangles for a second. It says before we find the trig ratios, which we've done the ratios, but we will divide these out. Let's think about these two triangles. What do you notice about them? So what do you notice about 15 compared to 7.5? What do you notice about 8 compared to 4? 17 compared to 8.5? Hopefully you're noticing that all of the side lengths in the smaller triangle are half the size of the side lengths in the bigger triangle. So what does that mean? That means these triangles are similar. The second triangle has side lengths half of the first. Okay, keep that in mind. This also means, if they're similar, this also means that the angles are all congruent. We don't necessarily know what angle A and B are as far as measures, but we do know that they're congruent. Okay, what I want you to do now is take out your calculator, and I want you to actually divide out these fractions. And we're going to go out to the 4th decimal place. Typically, trig ratios are written to 4 decimal places for whatever reason. That's just standard. So divide 8 by 17. That's about 0.4706. Divide 15 by 17. That's about 0.8823 or 24 if we round. Divide 8 by 15, that's about 0.5333. Okay? Do the same thing for the other set. So divide 4 by 8.5. That's about 0.4706. Divide 7.5 by 8.5. That's 0.8824. And finally divide 4 by 7.5. That's about 0.5333. So now the question is, what do you notice? Well, hopefully you're noticing that the sine of both angle A's are the same. The cosine of both angle A's are the same. And the tangent of both angle A's is the same. That goes back to the fact that these angles are congruent. So what that means is the sine, cosine, tangent values are dependent on the angle measure. It's dependent on the angle measure. No matter what the side lengths are, as long as your angle measure is, let's say, 30 degrees or 35 degrees, these will be the sine, cosine, tangent ratios. And actually, we kind of worked ahead a little bit. If you look at the next page of your notes, actually, we kind of already did all of this. If you want to transfer that information into this chart, that's fine, but that chart and then this question is actually what we've already done down here. So don't feel like you have to do that, but you can. When we come back together next time, we'll start right there with the second example.